In this video, we're going to be doing a deep dive on stop losses in Backtesting.py. I'm going to be covering 3 examples in increasing complexity and depth, which should cover everything that you need to know about stop losses in Backtesting.py. We're going to start off with a real simple example, just using the built-in buy function. And we're going to go all the way to extending the strategy class to provide a trailing stop, much like the inbuilt one from the library, which you may or may not have seen before. Now, I am going to assume some knowledge of Backtesting.py in this tutorial. So if you're completely new to the library, I have a free course here on YouTube that you can go watch. And then when you're ready to dive into more advanced topics, you can come back here. That might just serve as a good reference in case you get lost during this video. So let's go ahead and open up a terminal here and we can get started. Make sure that you've got backtesting.py installed. You can do that with pip install backtesting, and that'll grab all of the appropriate packages for you. And then we're ready to open up our Python file. I'll just call mine example.py. And then let's quickly write out some backtesting.py boilerplate in here, and we can get to the real meat of this lesson. So from backtesting, we'll import backtest, we'll import strategy, and from backtesting.test, we'll import Google data. This is just some really nice test data that comes with backtesting.py. If I print it out here, you'll see that it's a regular pandas data frame with open, high, low, close volume data. Feel free to use your own data, of course. I'm just going to use this because it's built in and I know everyone has access to it. The next thing we need to do here, as usual, is build out our strategy class. So create a class. We'll call it strats, and it'll inherit from strategy. So strategy, the same one that we imported up here. And then we need our 2 special functions as usual. So we need init. We're not going to do anything in init for right now. And we'll also need next, which is where the bulk of our trading logic is going to be located. So we'll pass on that as well. And then down here, we'll run our backtest. So bt is equal to backtest. We want to use our Google data, our strategy class that we've just defined here. And then we'll set cache equal to 10,000. And then do bt.run and bt.plot. And that'll get us going here, basically. So this strategy will not do anything at all. Unsurprisingly, it's not going to take any trades. It's literally empty. So let's add some very simple buying and selling logic in here, just to show how a very simple stop loss example might work. So if we go over here, we can say if we have a position, so if self.position, i.e. if self.position is not none, if it exists, well, I actually don't want to do anything in that case. But if we don't have a position, then I want to buy. So all you have to do there is self.buy, include the size. So if I say size of 1, that means buy 1 share. If you provide a float lower than 1 but higher than 0, it will interpret that as using that percentage of your available cash, whereas if you use an integer greater than or equal to 1, it will buy that many shares instead. And we can then add a stop loss in. So I'm going to grab the price here. So the price is going to be, let's use the closing price. So we'll do self.data.close -1. So we'll grab the closing price for this bar. And then we'll set our stop loss is equal to price minus 10, let's say. So $10 less than the closing price. And we'll set a take profit equal to price plus 20, let's say. And this way we get to see how the stop loss and the take profit interact with one another. Okay, so that should be good enough for just some real basic trading logic. Let's run it, make sure things are happening. And it'll look kind of insane. It'll make a real large amount of trades because as soon as it closes a trade, it will open a new trade on the next bar, and it's only going to stop if it gets stopped out or we hit the take profit. Now, it's important to understand the way Backtesting.py handles these stop losses and take profits, because the behavior might look a bit unusual if you're not used to it, and therefore you might not be able to get it to do exactly what you want. So let's just walk through a couple of example trades here and see if we can get the gist. So on this bar, it's closed out the trade, it's hit the stop loss, and therefore when it runs the next function of our strategy class, it doesn't have a position, and so it signals a buy signal, and by default, backtesting.py will execute your buy signals at the open of the next candle after the buy signal has been triggered. So the buy signal gets triggered here, and then it buys at the open of this candle. You may notice I didn't include any commission in this backtest here, and that's so it doesn't mess up the location of our buys and sells. If you add a bit of commission, it will adjust the buy price appropriately to account for that commission. But here I want to make it really clear where we're buying and selling. So if you look at the Y coordinate there, we're buying at approximately $460. So if we scroll over here, probably no surprise to see that we're at $480 over here, which is roughly $20 from where we set our take profit. Now you may notice this one here, and it looks a little bit strange if you don't quite follow the logic that we entered. So again, we're selling here, so a buy signal is going to be triggered when we run our next function, and therefore it's going to buy on this next candle. But if you remember the logic that we used in here for determining our take profit, well, it's the price plus 20. And the price is equal to the current closing value. So the closing value of this current bar that we're in, essentially. And so if we go over here, the closing price on this day, the 19th of April, was about $471 or so. So this will be the price point from which we do our take profit here. So what happens is that, well, it doesn't actually execute the buy until the next morning's open, which is at this level here. But our take profit is set at 20 above this level, so 491. Obviously, the candle ticks up to 491 during that time, as we've got the high up here. And therefore, our take profit is triggered on this candle when you wouldn't necessarily expect it to. So you have to be really careful with what price you set in here, because especially on daily data in the stock market, you can definitely have these big gaps, and that's going to cause a whole range of issues. For crypto or Forex, that's not going to be such a big issue, as the bars are going to be contiguous, they all go after one another, it's 24/7 trading. But where you're going to have big gaps in data like this, you want to be real careful about it. You can add the trade on close option in here. So trade on close is equal to true. And what that will do is that will execute the order at the close of this bar. So in this case, it would have bought here instead of buying at the next open. You do have to be incredibly careful with that though, because if you're using the current bar's closing price in your calculation, before the current bar has ended and you're buying at that time, you're going to quickly fall victim to look-ahead bias. And so that's something you're going to be super careful of when you use that option. I generally prefer not to use it. But that's something you can do if you're having a lot of these types of situations where the take profit is acting unexpectedly. You can also just use smaller time frame data. In general, that will be better for your backtest because it's more clear about what's going on. And you'll see that as we go forward and examine some of the problems that we have with the daily data here. Another thing that you might be interested in terms of execution of stop losses and take profits is that in general, the philosophy of backtesting.py is to be very pessimistic so that you don't get deluded by the results of your backtest. So if a stop loss and a take profit get triggered in the same bar, so if you have a very tall bar sometimes the stop loss and the take profit can get triggered in one bar. Hasn't happened here, but there are definitely bars where that can happen. Now the problem is, all we have is the open, high, low, close. We don't know whether it went up and hit the take profit first, or whether it went down and hit the stop loss first. And that could make a big difference to how our strategy performs over the backtest. So what Backtesting.py does is it always assumes that we get stopped out first if there's a clash like that. So if there's a bar that's big enough to encompass both our take profit and our stop loss, it will assume that we get stopped out first. It's not amazingly well documented, but if you want to find out more about how order execution works in Backtesting.py, I'd highly recommend diving into the code. If we go have a look here in GitHub, so if you go to this file here called backtesting.py, it's in the backtesting folder. And if you look for the broker class here, and you scroll down a bit, the broker class is basically responsible for processing all the orders. So we can go down here. I think it's somewhere at the very end here. You can see this, for example. So make sure the stop loss order is created first so that it gets adversarially processed before the take profit order in case of an ambiguous tie. So even if you can't read the code necessarily and follow the logic of it, you can read some of the comments in here that the author's written to make a bit more sense about how exactly things are going to get executed. And if you really want to understand backtesting.py, I really super recommend just reading through this file. It contains pretty much all of the core code for backtesting.py, and it's about 1600 lines long. But if you just want to focus on one class, I would recommend the broker class. That's where you're going to get the most bang for your buck. So if you focus on this class, have a read through how it works, how the orders are created, things like that. But if you don't want to do that, all we really need to know is that our execution is done pessimistically. So if you have a stop loss and a take profit that are triggered in the same bar, the stop loss will get triggered first. So I hope that makes sense. And again, this is the super, super easy way to do stop losses. You can put anything you want in here. It doesn't have to be just the price plus or minus a number. You can have an indicator defined. Let's say the average true range. So I don't know, if I had the average true range defined over here, I'll just set it to a number for now, but you can imagine this being some kind of function. Then I could set the stop loss here equal to the price minus 2 times the average true range. You can imagine how that might work. And in fact, that's what we'll be doing in the next part of this video. So the obvious problem with this self.buy here is that we can't change the stop loss once we've submitted our order, which isn't entirely realistic. Often you'll want to manage your stop loss based on what's happening next. I know a lot of people maybe like to move their stop loss to lock in profit. If you move significantly above your break-even level, lots of people like to set their stop loss there. Or you might want to set a trailing stop loss. There are a few ways of doing that. The method that I'm going to use here is one that's included with the documentation of backtesting.py. And that is, we're going to create a class which extends strategy and includes some special code for adjusting our stop loss here. And then you can inherit from that class and use it whenever you want in your future backtests. If that didn't make too much sense to you, don't worry, we'll plow through it anyway. So what we can do here is go up to the top of the file and we'll import some stuff from backtesting.lib. So we'll import the crossover and we'll also import a trailing strategy. So as you might expect, the trailing strategy allows us to do things like trailing stop losses. I'm also going to import the TA library here. We might as well spice up this strategy a little bit, make it a bit more interesting. And so instead of inheriting from strategy here, I'm going to inherit from trailing strategy. Now, we'll dig into exactly how this trailing strategy is built in the next section, and how you can make your own variants of it that do slightly different things. In this section, I'm just going to focus on how we use this trailing strategy so you can get a bit of an idea of how it works. So we'll get init to do something now. So I'll go in here, and first thing we'll want to do is call super.init. What that's going to do is it's going to call the init function for trailing strategy here and make sure that gets run before we do anything else. Now there's a function in trailing strategy called set trailing stop loss, and that's the one I'm going to be using here. So again, we need to use super because it's in the parent class here. So it's super.set trailing SL, and then you just give it a number. So I'm going to give it 5, for example. Now what this does is it sets the trailing stop loss at 5 times the average true range, which is just a technical indicator. Again, I'll go into how we can edit this to something more interesting a bit later on. And then all we really need to do here to finalize our implementation is inside next here, we also need to call the parent next function in here. And what that will do is on every single iteration, it'll make sure that our stop loss is set at 5 average true ranges below the current price value. Now, if we set this to run, hopefully we'll see some different results than what we saw last time. We need an import here. So I drag this on over. Let's have a look. So the easiest way to see if this is working is to check to see if our stop loss is more than $10 at any point. So remember, our stop loss is initially set at $10, but obviously, well, hopefully, the average true range will have changed it. So we should see variable length stop losses. So this one here, it runs from 608 all the way down to 561. Now, there's nothing weird going on with the previous candle, so we can only conclude that something at least has changed with the behavior of our stop losses. And you can see they're all different lengths. They're not exactly the same length. This one seems like a really long stop loss. This one's really short. And you'll see this even if you account for the effects that I mentioned earlier, where the stop loss placement is dependent on the close from the previous bar. Now we can pull this in and we can set it to be something really low. So we'll set it at 1 times the average true range. And hopefully we'll see a big difference. So if we go in a little bit more, we can see that all of these stop losses are very tight, except where we see lots of volatility. But our take profits are completely unaffected. Those should still be at a $20 take profit. As you can see here, it'll go from roughly $4.95 to about $5.15. Remember that it takes the previous closing value and uses that. Can't tell you how many times that has knocked me off a little bit. So okay, that's really great. We've got this trailing strategy here, and what that lets us do is set a trailing stop loss at a multiple of the average true range. And that may be really useful for some of you if that's what you want, but chances are you want a little bit more flexibility than that. So let's dive into the actual library code here for backtesting.py. So I'll drag that over here on this screen. Go over here. If you scroll down to roughly line 440 here in trailing strategy class, we can see that this one inherits from strategy, and then we're inheriting from trailing strategy. So it's got these class attributes here. Don't need to worry too much about that. The first thing it does is it runs and sets this function here. So it runs this particular function. All this function does is it calculates the average true range. Don't get hung up too much on what it's doing. Then there's this function, which takes in a number here, and all it does is it sets the value of this variable to whatever value you give it. Again, not very complicated. The next function here, well, it calls its parent next function. It gets the current index of the data that we're using, so basically how many bars we are through the data frame. And then for every trade in self.trades, so this is basically going to look at our open trades. If it's long, we'll then take that trade object and modify its stop loss to be the maximum of either the current stop loss or negative infinity. Basically, this is fancy syntax to say, if trade.stoploss doesn't exist, well, then this value should be negative infinity. So the max of whatever this value is, and self.data.close index. So the most recent close value minus the average true range at the current index multiplied by the variable that we set up here. And then obviously if it's a short trade, you have to do the opposite because the stop loss is going to go in the opposite direction. So rather than a minus, it's a plus. This code is something that's well worth reading and understanding. So I'm going to copy and paste this, and then we're going to make our own edits to trailing strategy here, and we can see how that affects our backtest. So let's go up here, and well, we don't need to import it now. We're actually going to define it ourselves. And I'll enter paste mode here just to make sure nothing goes weird. I have to zoom out a little bit. Okay, so we've got trailing strategy in here. Now, I'm going to simplify this function a little bit, and hopefully that'll give you some intuition about how it works. So instead of using the average true range, I'm just going to let us select a dollar value. So let's get rid of this function. We don't need it since I'm not using the average true range. I'll keep this function here, but I'll change the variable name. So I'll change it to dollar amount, and then I'll change this here, dollar amount, and dollar amount. If you're wondering why some of these variables have the underscores in front of the name, it's typically used in Python for when you want a attribute of a class to not be used outside of that class. So you want it to be kind of like a private variable. It's just a naming convention. Don't worry about it too much. So, okay, we've got this set trailing stop loss function. I'll get rid of this comment because it doesn't actually make sense for the reason that we're using it. We don't need that function anymore. We can change this here to be dollar amount, and we get rid of that. So we'll set the dollar amount to be, say, 20 by default. And then all we have to do is go down in here. So we want basically the same logic. We want to loop through all of the different trades. If it's long, well, we want the maximum of, well, this value remains unchanged. And then this one is where we can make our edits here. So instead of this, I'll just get rid of all this nonsense. And we'll minus self dot dollar amount. And I'll do the exact same thing over here. Looks like I misspelled dollar up here. So I hope this makes some kind of sense. I'm creating a subclass of the strategy class, and all it does is it has this dollar amount variable, which we can optionally set by calling this function here. And then in the next function, which as we know is evaluated on every bar, we go through all of the trades and we set the stop loss as appropriate, depending on whether the trade is short or long. All you have to do to modify the stop loss of a trade is just edit the stop loss attribute like we're doing here. So trade.stoploss is equal to whatever number you want. It doesn't have to be this crazy function involving max or min. It can be anything you like. And this will be set on the next bar. So now that we've gone ahead and changed this trailing strategy, let's see what happens here. So we don't really need to change any of this code down here. I'm going to set this to be, I don't know, maybe 3. So we're setting a trailing stop loss there of $3. So let's see what happens. As you can see, we've got quite the amount of trades here, and they're all very, very short here. So we can roughly estimate here using our trusty cursor. So 733, you'll notice that this one goes all the way down to 723. So this one is retaining our original stop loss value here of the price minus 10. The reason for that is the buy is getting triggered on this bar, and so it sets a stop loss at $10 below the price of the previous close. What would have happened if the trade would have carried on another bar is our trailing stop loss function would have kicked in. But because it only ran for this 1 bar, our trailing stop loss didn't get the chance. So let's see if we can find a trade that goes on for more than 1 bar at least. Let's change some of the parameters around so it's way more obvious. So I'll change this to maybe a stop loss of $50, and I'll change this trailing stop loss down to $2. That should make it real obvious which is which. So what you can see here is either the trailing loss is set in this bar at $50, but if the trade continues for more than 1 bar, so we see it didn't execute in 1 bar here, well then the stop loss is set at $3 below the close of this bar. So this bar closed here at 664, which means that as soon as it ticks open, it's immediately going to close because this is more than $3 less. So I hope that makes a little bit of sense in terms of how stop losses work when you're using a trailing stop loss and a regular stop loss. The interaction of the two can definitely be a little bit confusing if you haven't seen it before. So I hope those few examples I went through there were helpful in that. And obviously you want to mess around with the values yourself so that you can get an idea of how it works. Again, I'd highly recommend reading through the core code on the GitHub. So again, in this backtesting.file, if you go to broker.next, you can see the order in which things are evaluated. Importantly, broker is evaluated before strategy, and that's why we have this effect where this is in effect for 1 bar because this is sent straight to the broker, whereas on the next bar, these now get triggered. So that's probably more information than you'll ever need to know about stop losses in backtesting.py. I hope the video cleared up any confusions you might have about it, or at least gives you the confidence to try out different methods of using a stop loss to figure out how to get exactly the behavior that you're after. So with that being said, I'll see you in the next video.